So B says f of x, or if f of x is given as that equation, determine the values of x for which f of x is increasing. So f of x is increasing when its gradient is positive. So when the first derivative is greater than 0. This means that we need to find when the first derivative minus 3 over 2, or if we're going to take the first derivative, it's going to be minus 3 over 2 x squared. Now for the second term, it's going to be plus 6x, and this has to be greater or equal to 0. So actually we can just say greater than 0 because the one when it's increasing. Then we can solve for this by multiplying by 2 everywhere. That's going to leave us with minus 3x squared plus 12x is greater than 0. And then from this we could easily just factor out, let's see, we could easily just factor out minus 3x. So taking out minus 3x, from this we get x, from that we get minus 4. And we're saying this has to be greater than 0. Then what we can do is we can get our CVs and say it's between 0 and 4, right? So that's our CVs. And from this point, we just want to figure out what is the region of our answers. So between 0 and 4, and what is the nature of our function? It looks something like this because it's negative x squared, right? Here is the last step that we had before writing it in its root format, and our a was negative. That means we're writing it something like this. So in between 0 and 4, or is it outside the boundaries? We look at the region we're looking for. So when it's greater than 0, it's going to be within this bounded region, which means the values of x for which this graph is increasing is when x is in between 0 and 4. So when x is greater than 0 but smaller than 4.